Hello everyone. So last day we saw how to use interfaces in Golang. We had this interface greeter which had these two structs, and based on the type struct we are returning how to say good morning in different languages, one in English, one in Spanish. Do check out my last video too where I talk about this. In today's video we are going to see in the method that we defined in the interface, when you are implementing them through the structs, how can we use the concrete values of those structs inside the method to effectively use polymorphism. So let us begin. So this was last day's code. I'm going to delete this code and write a new one to show a practical example where we are going to use the values defined within those structs. So in today's use case, let us consider that we have an area calculator interface which can calculate area of rectangle or square. Depending on the input, depending on the type, it is going to use the value inside those structs and return the area. So let us create the calculator. So first we need to define the interface. So we are going to say type area calculator interface. We're going to define the method inside this. So the function is, let's say, calculate, short and simple name. It is going to return an integer. For now, we are considering that this calculate method can only return an integer, not a different type like float or something like that. So we are going to have two different structs which is going to implement this interface. So first, type rectangle struct. So as we know, rectangle can have length and breadth. So we're going to write length, breadth, int. Similarly, we're going to have square. So we're going to say type square struct. Since in case of square, length and breadth both going to be same, so we are going to consider only one field. And whatever is the value of this length, we are only going to square it because length and breadth is equal in case of square. Now let us override this calculate method using these structs. So func here, as we saw last year, it's going to be the receiver of the struct. So r rectangle and then this method with the signature. So this. So what are we going to return? We're going to return length multiplied by breadth. So length multiplied by breadth. In case of square, square s, it doesn't matter what name I give on this parameter, but to be more clear, I'm going to use s. So s dot length into s dot length. Short and simple. So what have we done? We're going to return rectangle, length and breadth multiplied with each other, and in case of square, length multiplied to itself. So now var, we're going to create a variable of type interface. So var a area calculator, a equals, we're going to say rectangle length 5, breadth 6, and then a dot calculate. So see how we do not need to pass these two parameters through this method, because we know calculate is always going to calculate the area. So if we already know this feature and if we already have this object, it doesn't make sense that we send these parameters separately through this method. That is the power of this type of polymorphism. So you're going to say empty dot printf percentage d, since it's an integer, put a new line, then a dot calculate. Similarly, if we want to see for a square, we're going to say a equal to square length 5. Same we're going to put here. So in this case, it will do the square of the area of a square and then return that value. So let us run it. So 5 multiplied by 6, 30. 5 multiplied by 5, 25. So this is how we can take advantage of receiver and call different concrete implementations of the interface method. Now one more thing I would like to mention. This receiver could be a pointer or could be simple variable of this type struct. Doesn't matter. In case we decide to make it as a pointer, for example, if we make this rectangle, so you see, as soon as we do that, it's giving a problem because this interface now is expecting a pointer, because when we are overriding this method, we are using a pointer receiver. So what we are going to do, we can simply make it as a pointer, and that's it. Now if we run this, it will work exactly like how I want it to. So this is how we can use the powerful feature of interfaces. I'm going to continue with interfaces more on future, and next day probably I'll come up with a video on embedded interface and how we can use it. So thank you for watching. Like, share and subscribe, the usual thing, and talk to you in the next video. Thank you.